Hello and welcome. Have you ever looked up at the sun and wondered about its story? For over 4.5 billion years, it's been the beating heart of our solar system, a seemingly eternal fireball giving life to everything on our planet. We see it every day, a constant, comforting presence in the sky. But the truth is, our sun is not eternal. Just like every star in the universe, it has a life, and one day that life will end. Right now, we're living in the sun's golden age. It's in a stable phase called the main sequence. To understand what that means, imagine a perfectly balanced cosmic engine. The sun is mostly made of hydrogen gas, and at its core, the immense pressure and heat are so intense that hydrogen atoms are forced together to create helium. This process, called nuclear fusion, releases a mind-boggling amount of energy. It's this energy that pushes outward, perfectly countering the crushing inward pull of the sun's own gravity. This balance is what keeps our star stable, shining with a steady light and warmth. To give you a sense of scale, our sun converts about 600 million tons of hydrogen into helium every single second. That's like turning the mass of the entire Great Pyramid of Giza into pure energy more than 100 times every second. This incredible process has been going on for billions of years, and it's the reason life could flourish on Earth. The energy it produces powers our weather, our ecosystems, and has fueled the evolution of every living creature. We are, in a very real sense, children of the sun. But this fuel, this massive reserve of hydrogen, is not infinite. The cosmic hourglass has been counting down since the moment our solar system was born. We are lucky to be here now, during this long, peaceful summer of our star's life. But winter is coming. In about 5 billion years, a monumental change will begin. The sun will have burned through most of the hydrogen in its core. This is the beginning of the end. Without the outward push from hydrogen fusion, gravity will win the battle. The core will start to collapse under its own weight. This collapse will dramatically increase the temperature and pressure at the center, heating it up to over 100 million degrees Celsius. At this extreme temperature, a new fusion process ignites. The sun will start burning the helium that was created over its lifetime. This switch to burning helium is a violent, transformative event. It releases even more energy than hydrogen fusion did. This new, intense energy will push the sun's outer layers outward with incredible force. Our star will begin to expand and expand and expand. It will swell to hundreds of times its current size, transforming from the familiar, friendly yellow dwarf we know into a terrifying red giant. Its surface will cool down, giving it a dim, menacing red glow, but its sheer size will be overwhelming. The inner solar system will be unrecognizable. Mercury, the closest planet to the sun, will be the first to go. It will be completely swallowed by the expanding star, its rocky body vaporized in an instant. Next will be Venus. The red giant will engulf it, erasing it from existence. And then the sun's fiery edge will creep dangerously close to us. The sky on Earth will no longer be blue. It will be filled, from horizon to horizon, with a colossal, burning red wall of plasma. As the red giant sun expands toward Earth, our planet's final days will begin. Even before it gets here, the consequences will be catastrophic. The heat will become unbearable. The sun, now a monstrous orb in the sky, will radiate such intense energy that it will literally boil our oceans away. Imagine all the water on Earth, every ocean, lake, and river turning into steam and escaping into space. Our beautiful blue marble will lose its vibrant color, leaving behind a barren, superheated rock. The atmosphere, our protective blanket, will be stripped away by the fierce solar winds. With no air and no water, all life will cease to exist. The surface of the Earth will become a molten desert, a landscape of glowing rock under the blood-red glare of the dying sun. It's a vision straight out of a nightmare. Yet it's a scientifically predictable future. What happens in the final moment? Scientists have two main theories. The first, and perhaps most likely, is that Earth will be completely engulfed by the sun. Just like Mercury and Venus, our planet will be swallowed and vaporized within the red giant's fiery outer layers, its atoms scattered into the star's interior. In the second scenario, there's a small chance our planet might survive, but not in any way we would recognize. As the sun expands, it also loses mass. This could slightly weaken its gravitational pull, potentially nudging Earth's orbit a little further out. If that happens, Earth might escape being swallowed, but it would be a hollow victory. It would remain a dead, charred cinder, tidally locked to the sun, with one side perpetually scorched and the other frozen in darkness. Either way, the Earth as a living world will be gone forever. After about 1 billion years as a red giant, the sun will run out of helium fuel in its core. The star becomes unstable, pulsating violently and shedding its outer layers into space. This material, composed of gas and dust enriched with heavy elements forged inside the sun, will expand outward in a beautiful, intricate pattern. This celestial spectacle is called a planetary nebula. It's a bit of a misnomer, as it has nothing to do with planets. Early astronomers with small telescopes thought they looked like round, planet-like disks, and the name stuck. These nebulas are some of the most stunning objects in the night sky, a ghost of a star painting the cosmos with its final breath. What will be left of our sun? At the very center of this expanding nebula, the collapsed core will remain. This remnant is called a white dwarf. It will be an incredibly dense object, containing about half the sun's original mass packed into a sphere roughly the size of Earth. A single teaspoon of a white dwarf would weigh several tons. This stellar core will be extremely hot, glowing with a brilliant white light from its residual heat. It will no longer be producing energy through fusion. It will simply be cooling down like a dying ember. This white dwarf will be the new center of our solar system, but it will be a desolate kingdom. The outer planets, like Jupiter and Saturn, might survive, but they will be dark. Frozen worlds orbiting a faint, distant point of light. For trillions of years, the white dwarf will continue to cool, fading from white to yellow, then to red, until finally it will become a cold, dark, invisible object known as a black dwarf. At this point, the solar system as we know it will be nothing more than a graveyard of dark planets and debris, drifting silently through the cosmic void. But in this destruction, there is a seed of creation. The elements that the Sun scattered into space through its planetary nebula, the carbon, oxygen, and other atoms that were cooked in its core will travel across the galaxy. Over millions of years, this cosmic dust and gas will mix with other stellar remnants. Eventually, gravity will pull this material together, forming new clouds, new stars, and new planets. The atoms that once made up our Sun, and perhaps even our Earth, will become the building blocks for new worlds billions of years in the future. In a way, our end is just a beginning for something else. We are made of stardust, and to stardust we shall return. 5 billion years. It's a span of time so vast it's almost impossible to comprehend. Human civilization has only existed for a few thousand years. Our entire species is just a fleeting moment in the life of our planet. So, this story of the end of the world shouldn't be a source of fear or anxiety. Instead, it should be a source of perspective. It's a powerful reminder of how incredibly precious and fragile our existence is. We are living in the perfect moment, on a perfect planet, under a perfect star. Earth is the only home we have, and it's in its prime. This cosmic perspective encourages us to appreciate what we have right now. Will humanity find a way to survive? Will we develop the technology to leave our solar system and find a new home among the stars before the Sun begins its final act? That is a question for the distant future, a story for our descendants to write. For now, our job is to be good stewards of this beautiful world. When you wake up tomorrow and feel the warmth of the sun on your face, take a moment to appreciate it. That light and warmth is a gift, a product of a star burning billions of miles away, working tirelessly to sustain you. We are participants in an incredible cosmic journey. Thank you for joining me on this exploration of our cosmic future. If you found this journey as fascinating as I did, don't forget to hit that subscribe button and ring the bell. We have so many more wonders of the universe to explore together. Until next time, keep looking up.